All right, now listen up. This is part 2 of the Unit 1 revision, and we only have a few topics left to finish Unit 1, even though they're actually very important. And let's get started right away. First is one of the effects of moments of forces, called the turning effect of a force. This is what we call a moment, which is when an object rotates because of force, not move in a straight line, but instead it rotates. Let's look at the checklist first before we go through things. Describe moment as the measure of the turning effect and give everyday examples. Easy. Define moment as force times perpendicular distance. That's the equation. But you'll notice that this is how he wants you to define a moment. So it's moment equals force times perpendicular distance from a pivot. Recall and use the equation. Apply the principle of moments to situations with one force on each side, including the balancing of a beam. State when there is no resultant force and no moment, it's in equilibrium. This is very important. Apply the principle of moments to other situations, including cases where there's more than one force. Now, I haven't gotten a lot of questions for us to practice with, but I've gotten a really hard one to practice with, like a super hard one in one of the more recent variants. Describe an experiment to demonstrate that there is no resultant moment on an object in equilibrium. This is very easy. What's meant by center of gravity? A point in an object where weight is considered to act. Describe an experiment to determine the position of the center of gravity of an irregularly shaped plane lamina. If people don't know what lamina is or a plane is, they simply mean a sheet of paper. Lamina is anything that is laminar, as in thin, all right? So it doesn't have a lot of thickness. And plane means it's 2D. It's not three-dimensional. It's not something curved, like a curved piece of paper. It's just flat. And describe qualitatively, with no numbers meaning, the effect of the position of the center of gravity on the stability of simple objects. So what makes an object more stable and what makes an object less stable? So let's start. First, what is a moment? A moment is the turning effect of a force. So when you apply a force on an object, naturally it moves. Like we've talked about this yesterday or like last time. When you apply a force on an object, it moves up, down, left, right. It accelerates in the direction of the resultant force. But if an object has a pivot, and what's a pivot? A pivot is a point that is fixed. So think of a door. It has a hinge. That's a pivot. Think of a steering wheel. Its center, or any kind of wheel. The center is its pivot. Think of this pen that I'm holding, the stylus that I use to draw on my tablet. If I hold one end of it and make sure it's fixed, applying a force makes this pen rotate around this point. This is called a pivot. So a pivot is just a fixed point where the object will rotate around. So when you apply a force on an object and it has a fixed point, it rotates. Now, the rotation could either be clockwise, so in the direction of a clock, or anti-clockwise, so opposite direction of a clock. So to the left or to the right, it's an easy way to think of it. Now, when you calculate a moment, it's calculated using force times perpendicular distance to the pivot. So it depends on two things, how much force you're applying and how far away you are from the pivot. The further away you are, the greater the moment. So you rotate harder. If you think of a door, I should have drawn a door here. If you think of a door, for example, that's open, and you apply a force on this door, it's easiest to apply a force on the door at its very end, where the handle of the door is. You don't pull a door from its hinge. You don't do that. You do it here. Why? Because the further away you are from the pivot, the rotation gets stronger, which means it rotates faster and easier and such. So that's what a moment is. How do we calculate it? Force times, why is this distance perpendicular? Because the angle, and let's zoom in some more. If this is your pivot, and this is the force, the distance between them has to be perpendicular to the line of action of the force. So the line of the distance and the line of the force have to be perpendicular to each other. So let's erase this for a second. And let's solve a very quick example on this diagram. If this distance, for example, is 3 meters and the force was 10 newtons, calculate the moment. You would say moment is force times distance. It would be 10 times 3, which gives me a value of 30. What's the unit? Since it's force times distance, this means it's Newton times meters, or whatever unit of distance I decide to use in this question. So it's meters here, could be centimeters, another question, so on. So 30 newtons, centimeters in this case. Okay, good. Now, if you apply a force on the pivot, there's no moment. What do I mean? Because if the force is on the pivot itself, if you have a pivot here and you push the object where the pivot is, it doesn't rotate because the distance is 0 and therefore the moment is also 0. So again, please remember, the distance has to be measured from the pivot to the force, not from some random point X to the force, okay? Yeah. Why do I have this special case on this side? Like I've written special case. Why is this special? Look at the force. Look at the force. Look at how terrifying this is. Instead of drawing a force that's perpendicular to the door or this beam, the force is at an angle to the surface. So if I tell you that this distance over here is 3 meters and the force here is 10 newtons, again, same force, same distance, but the force is not perpendicular to the beam, it's at an angle. So if it's at an angle to the beam, لو هي واخدة angle كده للبيم جاي كده بالجنب, I cannot say 10 times 3. If I say moment is force times distance وقلت 10 times 3, دي absolutely غلط, wrong. تنفعش. 0. طب أعمل إيه يا مستر? Well, first you need to identify أنهي distance اللي أنتوا محتاجينه. Like which distance do I need? The distance that you need to measure is this. The length or the line of action of the distance and the line of action of the force must be at 90 degrees to each other. So the distance that you measure is right here. بس مستر دي في الهواء مش جوه الأوبجكت. We don't care إنها جوه الأوبجكت أو في الهواء. We don't. As long as the line of the distance and the line of the force are at 90 degrees, that's what we do. And this is the hardest thing I can do to you, by the way, in an exam. The most difficult thing I can do is draw a force that's at an angle to the surface. طب how do I find this distance? يعني let's continue with the example. We already said it's not 3. خلاص يعني distance is not 3. So what do I do? عشان تفهموا logic around this, we need a little bit of math. If you look closely at this, المفروض الحصة اللي فاتت تفكركم بحاجة. This looks like a what? A right-angled triangle. خلاص? And the distance you want is here. If this angle is 30 degrees, ودي x, وانتوا معاكوا دي ب3, if you turn this triangle على جنب, so you can see it better, صح كح تح تاو بالظبط, or toa. I keep saying it wrong every time. Sine, cosine, tan. So if this is 30 degrees, and this is the distance x that you want, and this is 3 meters, how do you find the x? بنقول إن x is equal to 3 sine 30. So we do the same thing here. If and only if, it's a very rare case, but if and only if the distance دي is at an angle, like, or the force is at an angle, بنجيب الديستانس دي بإن احنا نقول إنها length دي times sine 30. So it's 3 sine 30. I'll pull out my calculator. So 3 times sine 30. يطلع 1.5. So now the distance is 1.5. دلوقتي ممكن ترجع تحسب المومنت عادي. هتقول 10 times 1.5, which is 15 Newton meters. Have a good day. بس الفكرة كلها إن you need to do what? To find the correct distance. This is the hardest thing I can ever do, and this has only ever showed up twice in past papers so far. Once in a multiple choice question without calculation. You just choose the correct distance. And second, in a written paper 4 question, which is the question that we will see right here. بس المرة دي the angle was 60 degrees and not 30. Next. So now we understand what a moment is and which is the easiest part to pull or rotate an object, the farthest point away from the pivot. بس then لو فاكرين بقى هنا كان قال لي state what this. State that when there's no resultant force and no moment, it's in equilibrium. So what is equilibrium? ما بيننا وبين بعض, this is just a state where an object is balanced 100%. أما الobject to a perfectly balanced, no problem. So if an object is balanced, معناها حاجتين. It is not accelerating لا لقدام ولا لورا ولا up ولا down ولا left or right. You can think it's not moving. But this means the resultant force is zero. There's no force. And second, it is not rotating. مش بتلف. There's no resultant moment. The moment is zero. يعني إيه كلمة resultant moment? Resultant moment معناها إن clockwise moment equals the anti-clockwise moment. This means that you can have more than one force on an object ونقول إن clockwise قد anti-clockwise. And tell you what, this is one of the most common concepts that you need to keep in mind وإحنا بنحل moment questions في physics. قصدي إيه? Here's a very simple example, very common too. يديني beam, like a bar, a ruler, anything. Gives me a pivot, usually in the center. بس sometimes the pivot ممكن يبقى at the side. عادي جدا. I'll show you the same example twice. مرة في force هنا to the right لتحت ب 10 newtons at a distance of 3 meters زي ما قلنا من شوية. And then another force downwards برضو called F at a distance of 2 meters. A very common question is the examiner telling you, this is in equilibrium. Find F. The way we solve this is by simply saying in the clockwise moment equals the anti-clockwise moment. And what's moment? Force times distance. فيلا clockwise force times distance ده 10 because it's on the right side فده بيخليها تلف clockwise. فنقول force times distance اللي هي 10 times 3 the two values are given equals anti-clockwise so force times distance. I don't know the force إن دي بتلف anti-clockwise دي بتلف شمال rotating the other direction. So it's just called F times ايه distance بتاعتها من F للpivot 2. I think you can clear this up by easily. And you can figure this out easily. 10 times 3, 30, divide by 2. You have F equals 30 over 2, which is 15 newtons. شفت نستخدمها ازاي؟ Very good. If I give you the same style of question, but this time the pivot's on the side. So I'll give you two forces. D, 10 plus newtons at a distance of 3 meters. واخدين بالكم I'm using the same numbers محدش يقول لي حاجة. And then F upwards because خدوا بالكم بقى the pivot's on the side فلو أنا زقيت لتحت I need another force لفوق upwards عشان تبالانس ال upward و downward forces محتاج الاثنين ودي ب F at a distance of 2 meters هنا. So pretty much almost نفس الexample. Find F. المرة دي ال 10 is also clockwise عشان على اليمين بس مستر دي على اليمين بس بصل فوق so this rotates anti-clockwise. طيب يجي حد يقول لي مستر أنا عندي مشكلة I can't find exactly الفورس ده clockwise ولا anti-clockwise I can't tell like mentally ببص على الورقة and I go like I don't know if this is clock or anti-clock أعمل إيه like before we solve this أعمل إيه. Here's what you do. Take a pencil or a pen, put it on top of the diagram مكان البيم أو البار and then hold it where the pivot is. فأنا ماسك أهو على الناحية الشمال زي ما البيفت هنا على الناحية الشمال. And then what؟ بصباعك التاني try applying a force في نفس الدايركشنز اللي دول موجودة. So first جرب ال 10. Push your pen down. Push your pen down. ايه ده؟ دي لفت ازاي؟ clockwise. رجعها تاني. So I know this is clockwise. طب جرب بقى push ال F من الناحية دي at the very end بس up زي ما هو عمل. Oh دي لفت معايا ايه؟ anti clockwise. Do this on your paper. There is no shame انك تحط القلم او marker على الحاجة وتشوف دي clock ولا anti clock. Get it right. مفيش shame في الموضوع. Okay. So again, we'll follow the rule. Clockwise moment equals anti-clockwise moment. Mean a clock 10 times 3. I think you're professionals at this by now. Equals F, because ما اعرفهاش, times. And now I ask you the question. انتوا بقى. الديستنس هنا بكام اللي محتاجها عشان احسب المومنت الانتي كلوكوايز بتاعت F؟ انا مبسوط. I am very happy and proud. 5. صح 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 صح. Love this. I love this. Thank you. 5. لازم الديستنس تبقى من الفورس للبيفت. So don't fall this for this trick. It's a very common trick برضو. 3 و 2 يدوني 5 and you get the idea. يبقى F equals 30 over 5 المرة دي, which gives us a 6 newtons. أديكوا شفتوا cases where the pivot is in the center, pivot على جنب, وفكرة الديستنس تتعمل صح and using equilibrium to find the force. Next بقى. What is center of gravity? Center of gravity is defined as a point in an object where weight is considered to act. You need to memorize this. It's not very common, but there are times where the examiner asks you to define center of gravity or center of mass في الحاجة القديمة. المنهج القديم. Where is the center of gravity and what is it? If I draw the force of gravity or weight acting on an object, we always draw it coming from a specific point in the object, and that's the center. Even though في الحقيقة gravity بتشد كل حاجة تحت, like gravity pulls everything down في كل نقطة في الobject, but we simplify ونجمع البوينت دي في حتة واحدة ونقول gravity بتact at that point. اشمعنى at that point and why at the center؟ عشان دي technically speaking البوينت لو حطيت عندها pivot, يعني لو حطيت pivot in the center, الclockwise والanti clockwise هيعمل balance. عشان حتة الماس اللي على اليمين وحتة الماس اللي على الشمال قد بعض. The both sides قد بعض. They're equal. So they have equal masses. فالclock قد الايه؟ anti clock. تمام؟ So why is it exactly in the center? Because this is where the mass is perfectly balanced يمين والشمال. 100%. وفوق وتحت على فكرة كمان. So for regular objects, think the square, think a beam, think a circle, it's in the center. If you have an irregularly shaped object, حتى الشيب بتاعها مش uniform أو الماتيريال مش uniform, it's always roughly near the heavier part. يعني لو قسمت ده كده, so maybe it's somewhere here. Could be even here حتى, بس مش لازم نجيبها بالظبط. Most of the time, at least qualitatively for now, هنجيب the center of mass roughly with a sense of, oh yeah, it's not exactly in the middle. That's impossible. هتبقى actually towards the heavier side شوية. You have a range. طيب. تقولي بس مستر, what's this experiment بقى اللي هو بيقول عليها? An experiment to determine the position of the center of gravity of an irregularly shaped plane lamina. That was a mouthful. قصدي ايه بدي؟ قصدي ان if you have a sheet of paper like this one, for example, pull out a sheet of paper now. اهو. And oops, اتقطعت مني وحش. اتقطعت مني اكتر وحش. ما بقتش حلوة خالص البيبر دي. Look at this. It's irregular in shape. Where's the center of mass? لو أنا بحل بالحب وخلاص, like just randomly كده, I would say maybe it's somewhere here. Like maybe you can't see it clearly. Oh, it's too bright. It's somewhere here. But how can I tell? This is how. You take that sheet of paper and you hang it from a stand with a pin. Make sure it's free to move. يعني انت كده literally بتخرم الشيت of paper and you allow it to hang and move freely كده براحتها. And once it comes to rest, the center of mass will be somewhere here. هتبقى somewhere هنا في الخط ده. احنا عارفين انها هتبقى somewhere في الخط ده. ان it came to rest. ان طالما السنتر of mass تحت البيفت, this is your pivot, مش هتروتate. طب how do we find that? How do you draw this line? You hang what we call a plumb line. This is a thread with a mass at the end. كورة كده وثريد. عشان تساعدني أرسم. بروح أعمل إيه؟ باجي على آخر اللاين ده أعمل مارك على الورقة. Because you know what? It's very hard to draw a line on a sheet of paper hanging in the air حتى لو على stand. So we just make a mark. حتة كده صغيرة تحت. And then we repeat the steps again. بس المرة دي بنعلق الكارد دي أو this piece of paper from a different end or different corner of this sheet of paper. And after you do that, you make another mark. فكده هيبقى عندي a sheet of paper with at least 2 marks. أنا عايز 2 بس. And when I make 2 marks, هنروح راسمين اللاين من A للمارك بتاعتها ومن B للمارك بتاعتها. And I mean لو علقتها من C, which is the other corner, والمارك بتاعتها. And if your if your experiment is very accurate, the center of mass هتطلع perfectly on the intersection. Now I'm going to spoil something. في paper 6, في paper 6, this experiment is sometimes, occasionally referenced. بس هو اللي بيعملها يعني like you don't do anything, you don't describe it, you just follow along with the instructions. جا في مرة راح عمل third line, راح عمل third line كده. It didn't intersect perfectly with the other two. يبقى فين center of mass? Somewhere here. Somewhere في الحتة دي. في like التراينجل الصغنون ده. بس. That's how you find the center of mass of an irregularly shaped plane lamina زي ما بيقول. طيب. آخر حاجة كان طلبها مني فوق هنا, if you remember, was to describe the effect of the position of the center of gravity and stability on simple A object. Stability معناها إيه؟ إن the object does not fall over when you tilt it. لما تميلها. It's not about pushing it hard. It's not about the force. It's about, hey, أنا عندي إزازة مية. خلاص. And by the way, a lot of you do this already when you do the bottle flip challenge. And لحد دلوقتي people still do the bottle flip. But the idea is what? لما البottle بتميل, like if you just tilt it and you let it go, it's supposed to go back and to its original position. If you push it too far, هتقع. And we say that it's now unstable. يعني when you push a bottle too far or an object too far, بتقع. بتقع إمتى؟ لما السنتر of mass بتاعت البوتل دي تعدي الإدج بتاعت الأوبجكت, which we can consider a pivot. فبتعمل moment فبتقع. That's it. How can I make this bottle more stable? 2 ways. You lower the center of gravity or center of mass. يعني نحط حاجة تقيلة تحت. Get a piece of stone or rock ويلزقوها تحت في الإزازة من تحت. مش هتقع. Almost ever. Unless you literally like push it to the side. When you lower the center of mass, تبقى extremely stable. And second, make the base wider. Instead of a thin bottle, I'll get a much larger bottle. خلاص. دي bottle محدش يقدر يتحجج انه هيبقى dehydrated بعديها لو شرب منها ميه. But still, will this topple over easily? لا طبعا. Because it's so wide, it takes a long distance for you to push the bottle عشان تقع. Whereas when a bottle is very narrow, لما اجيب حاجة رفيعة كده. Why does this fall over very easily? علشان الديستنس من السنتر اوف ماس للإدج بتاع البطل صغير قوي. It's very easy to push it just شوية الديستنس دول and it falls over. هنا you have to push it all this way for it to fall over. So an object is more stable when it has a lower center of mass and a wider base. This is why Formula 1 cars are very wide and very low, close to the ground. so that they're very stable. حتى لو الأرض مالت معاهم ما تقعش، ما تقلبش. Let's solve a question. This is from November 22, variant 1. So, first, a rock climber has a total mass of 62 kilograms. She holds herself in a horizontal equilibrium position against the vertical cliff. She pulls on a rope that is fixed to the top of the cliff and presses her feet on the cliff. So right now, the rope ده عامل force. Let me change the color of my ink. The rope ده عامل force this way. Let's call it force T. That's pulling her up. طب مستر أنا مش شايف إن دي moment ولا أي حاجة. أقول لك لا, this is a moment question. شيل البنت خالص وحط مكانها just a rod. Look at this. مش هي دي سؤال pivot هنا اهو because this is fixed. She literally says she pulls on a rope that is fixed on top and presses her feet against the cliff. Her feet are on the cliff, دي fixed. وهي ليها weight هتعمل clockwise moment وهي بتشد لنفسها لفوق anti clockwise moment. ما يخضكش منظر الأسئلة لو سمحتوا. You can always simplify it to an easier diagram to deal with. Okay? الأول بيقول calculate the total weight of the climber. إيه ده؟ ليه بيقول لي هات الweight؟ Because he gave me the mass. زي ما انتوا فاكرين W equals mg. الm ب 62 والg ب 9.8. But since this is November 22, this was before the g was 9.8, المسألة دي g ب 10. I'm going to use 10 عشان simplify بس ال question دلوقتي. This is why it's only 1 mark. عشان all you need to do is take 62 اعملها times 10, just add a 0. That's it. عشان كده أسئلة الويت قبل كده معظم الوقت كانت تبقى 1 mark because it's a very easy thing. Just add a 0. Now ممكن تبقى worth 2 marks عشان 9.8 isn't as easy to do in your head زي just times 10. طب نكمل. State the 2 conditions needed for equilibrium. ايه 2 conditions؟ يلا. Clockwise sorry. Resultant force equals 0 أو ممكن تقولوا no resultant force resultant moment equals 0 أو نقول no resultant moment. Both answers are okay. مش فارق معايا تقولوا no أو equal 0 الاتنين صح. The climber's center of mass is 0.9 from the cliff. طب أنا همسح اللي أنا عملته ده ثانية. أنا مش عايز أمسح كل ده. So let's just erase الشخبطة دي. I kind of spoiled جزء من المسألة when I drew the weight. بس يلا. If the center of mass is 0.9 meters from the cliff, ده معناه إن النقطة اللي هو علم عليها دي center of mass, this is where her weight is. يعني this is where a force of 620 newtons is. هو ما رسمهاش. He just told you where the center of mass is وقال لك calculate weight ودلوقتي ممكن يطلب منك ايه؟ Calculate the moment about her feet. Stop right here. انت ممكن تطلع لي في اول مسألة تقول لي مستر انت ايش عرفك بقى؟ Because some of you might think that. انا ايش عرفني ان the pivot عند رجليها. I don't know. He didn't say that. Like لحد دلوقتي he did not explicitly say take the pivot at her feet مثلا. ما قالش. And you're not expected to logically figure it out على فكرة. احنا برضه this is IGCSE Physics Cambridge. Cambridge likes to be very clear even though they try to confiscate information كده في السؤال language, but it's still clear. كلمة about wait, where is it? Marker around. About something means إن ال something ده الإيه؟ البيفت. About مثلا point B, that B is the pivot. About X, that's the pivot. About your hands, that's the pivot. About your shoulder is the pivot. About her feet is the pivot. طيب. Let's calculate the moment. هنقول يلا force times distance 600 and oops. You know, when your brain thinks faster than you can write. 620 times 0.9 يطلع 558. Thank you. 558 Newton and the distance centimeters and Newton meter. Perfect. easy. Next. الحتة الأخيرة بقى دي اللي صعبة. This is the hard part. And let me teach you something. هنقولها when we start revising past papers. Like إن شاء الله يعني after we're done with part 1 والrevision بتاع syllabus هنعمل part 2 where we like just solve past papers ونبدأ ندقق في ايه details ولازم تاخد بالكم من ايه والكلام ده كله. A 3-mark question, sorry, a 2-mark question is direct, meaning you plug in a formula, you write your working, you find an answer. 1 mark usually for the answer, 1 mark for either the working or the substitution بتاع equation. A 3-mark question has a trick involved, or like a single extra mark that makes it a bit more difficult. فبيقول the line of the rope meets the horizontal line through her center of mass at a distance of 1.2 meters from the cliff. مديني distance الهوريزونتال دي اهو دي, and this is the force اسمها tension. Next. The rope is at an angle of 60 to the horizontal. Determine the tension in the rope. طيب طالما هي equilibrium يبقى what can I say? إن the clockwise moment equals the anti-clockwise moment. This is a natural progression لأي أسئلة moments. He'll usually ask you to get a moment of one force, and then I'll use equilibrium to find another force. What's clockwise? والله المومنت بتاعت her weight. We just got it. يعني her weight is trying to rotate her clockwise. فنقول 558 هنا equals. What's anti-clockwise? هو عايز determine the tension in the rope. This is just another way of saying the force. فنقول F اللي هي tension times. What's the distance? It's not 1.2. لو عملته بقى اللي أنا قلت لكم عليه من شوية which is أنا عايز الديستنس اللي هي perpendicular للforce اللي هي دي. This distance over here. And it's a triangle. Oh, here's the triangle. If you can't see it with your eyes, here it is. يبقى الديستنس دي بكام؟ ب 1.2 اللي هي الديستنس الطويلة لتحت sine what's this angle 60 بالظبط يا أحمد excellent. So نرجع تحت ونقول the distance is 1.2 sine 60 وده اللي مخلي السؤال صعب and you need to figure out حتة الديستنس دي. Is it a common trick؟ لا خالص. But that's what makes it even harder because people don't usually see it very often. طبعا when you have a very large number like this you just round it up to 3 significant figures فأقول 537 newtons. Does her weight have any effect on the moment? Absolutely yes. كل ما الويت بتاعها يزيد المومنت بتاعها هيزيد. بس تيجي تقولي لي طب انت ليه ما حسبتش الويت هنا؟ We already did. شايفه المومنت that we calculated من شويه؟ That was the moment of her weight. So we already calculated the clockwise moment for I and we just copied it down here. أنا كنت ممكن بكل سهولة over here أقول 620 اللي هي الويت بتاعتها times 0.9 اللي هي force times distance. So we already did that. فموجودة خلاص. If she was heavier, like if she had more weight, you would need more force. If she was lighter, she had less weight, هتحتاجي force أقل. You're welcome. Very good. كده خلصنا المومنتس. Now, let's move on to energy, work, and power. Now, you might look at the checklist and go like, oh my God, a checklist ده. So it looks very large, but it's actually not. It's just full of like, افتكر equation بتاعت الانرجي. افتكر ان الانرجي cannot be created or destroyed. Tell me how to use energy cannot be created or destroyed, like stuff like that. وافتكروا لو سمحتوا how to use the checklist. بعد ما تراجعوا, go back to the checklist and read every sentence. And pick if you clearly understand that sentence or not. لقيت نفسك مش فاهم السنتنس, go back and revise and solve. Yeah. State that energy may be stored as kinetic, gravitational, chemical, elastic, nuclear, electrostatic, magnetic, and internal. حاضر هندefine these دلوقتي. ايه stores دي? Describe that how energy is transferred between stores during events and processes, including examples of forces, which is called mechanical work, electric currents, which is called electric work, heating, and by electromagnetic sound and other waves. يعني waves. كل دول معناها waves. Know the principle of conservation of energy. Energy cannot be created or destroyed. And apply this principle to simple examples, including the interpretation of simple flow diagrams. يعني from what energy to what other type of energy to what other type of energy كده يعني. Recall and use the equation for kinetic energy, half mv squared. So we have to remember this formula. Recall and use the equation for the change in potential energy, gravitational potential energy, mgh. Know that the principle of conservation of energy, نفس الجملة اللي فاتت دي، بس apply this principle to complex examples including multiple stages. وهنشوف example of a multiple stage يعني هنتكلم عنها. يعني let's say you have a man that's running خلاص up a slope بعد كده خلاص and then he stops to rest, or maybe he could jump off that slope. You can do whatever you want to the guy يعني في الدescription بتاعنا. And this is what we mean by complex multiple stage conversions. Understand that mechanical or electrical work is equal to energy transfer. ده ال definition بتاعتها. What is work? Energy transfer. Recall and use the equation for mechanical work, which is force times distance. Define power as the work done per unit time, and also as the energy transfer per unit time. Recall the equation, power is work over time, I forgot the slash here, and energy over time. هتلاقوا slash تحت في الحتة النظيفة شوية. Understand qualitatively the concept of efficiency. يعني تبصوا على حاجة تعرفوا if it's efficient or not. يعني does it waste a lot of energy ولا لأ. And second, define efficiency as ومديني الرول useful energy output على total energy input. Why did I keep forgetting these slashes? Times 100%. Recall and use these equations. طب تعالوا نبدأ بالenergy. What is energy? قبل ما اتكلم على التايبس عشان بس ما بينه وبين بعض كلام كده. Energy is something that you need to do in order to do work, to perform some kind of action, regardless of whether or not this action خلاص is electrical بتشغل monitor or computer that I'm using here or such, or mechanical like you're pushing an object, lifting something, or waves related يعني I have a light bulb on, it's turned on light, or heating related, so when I'm done I'm gonna go make myself some dinner, هسخن شوية أكل. So all of this is considered different types of energies. Energy is something you need to perform different actions. And then the different types of energies we have to memorize. اللي هما kinetic. What is kinetic energy? It's the energy of speed. The faster you're moving, the more kinetic energy you have. تتحسب ازاي؟ Kinetic energy is equal to half mv squared. What's m? Mass. What is v? Velocity or speed. So clearly it depends on your speed. Gravitational potential energy. معتمد على ايه؟ على height of the object. So if you have a box that's on the ground, for example, بنقول ان دي عندها zero gravitational potential energy. When you lift it up into the air and it has a certain height, بنقول عندها a certain amount of gravitational potential energy حسب الهايت وحسب الماس بتاع الأوبجكت. Okay. Energy in general بقى, whether it's kinetic, gravitational, otherwise, is measured in a quantity called joules. بس طبعا please خدوا بالكم. Any units with special names, نيوتن، جول، هنشوف بعد شوية واتس، الكلام ده كله لازم اكون انا شغال بالاس اي يونتس. فاكرين الاس اي يونتس اللي قلناها قبل كده؟ الستاندرد يونتس اللي قلناها قبل كده دي لازم ايه نشتغل بيها. يعني مترز وكيلوغرامز وسكندز. Chemical energy is the energy stored in food or fuel or batteries or your body, for example, or other animals or wood. Anything that you can burn is called chemical energy. يعني أنا في جسمي دلوقتي chemical energy. I'm talking صح؟ I'm talking a lot صح؟ وأكتب. What energy am I losing from my body because of my actions? Chemical energy. Elastic or strain. This is when you stretch an object or bend it. And if I have a spring or a rubber band, if I stretch that spring or rubber band, that is called elastic potential energy or strain energy. Okay. So ruler, تنيته، حاجة شدتها, and so on. Next. Nuclear energy. What is nuclear energy? This is the energy في ايه بالظبط بقى؟ يعني ايه nuclear؟ Inside the nucleus of an atom. عشان كده اسمها nuclear. جوه الاتوم في protons ونيوترونز جوه النيوكليوس, but there is also a lot of energy that is used to bind البروتونز والنيوترونز مع بعض. اسمها في الحقيقة binding energy, nuclear binding energy. بس الانرجي دي ما بنقدرش نستخدمها as is, لازم نخرجها ونحولها لحاجة تانية through reactions called nuclear fission and nuclear fusion. هناخدهم in detail في unit 5. Internal energy is another way of saying thermal or heat, which is how hot something is, صح؟ لا. في unit 2, we'll discuss the concept of heating. When you heat an object, the molecules vibrate faster. That's why it's called internal, because دي الانرجي اللي جوه المولكيولز اللي جوه السبستانس. The more you heat an object, the faster the molecules vibrate. So it's known as the total kinetic energy of the molecules in a substance. عشان نبسط هنقول heat وخلاص, بس you understand ان heat ليها معنى تاني at a molecular level. Electrostatic and magnetic. ممكن تبص لي, all of my students, whether انت هنا في الريفيجن جديد او حتى student من عندي في المدرسة من الاول, تقول لي I have never seen كلمة electrostatic ولا magnetic energy, ولا في مسألة شفناها من 2009 لحد 2022, and you would be right. الاكزامينر حاططها ككلمة علشان again المفروض لما يحط curriculum you keep his base, يعني you cover all his bases ويقول كل الديتيلز صح, عشان ما يجيش scientist او ما يجوش entity تانية تقول لهم ايه ده, these are not the energy stores الوحيدة اللي موجودة. Electrostatic is just another way of saying electric. Electric في ايه؟ اللي في الcharges. لما charges تتحرك in a circuit or a battery pushes a charge, او يبقى عندي electric field بيزق charges, the energy in that charge is called electrostatic. خلاص. والمagnetic يعني ايه؟ same idea. لو انا جبت two magnets north and south وثبتهم, or like just got a magnet the north pole هنا and I just keep it fixed, if you have another magnet that you're holding and you let it go بتقرب, صح? So what kind of energy was converted? نسميها magnetic energy because it was pulled due to the magnetic field to kinetic وهي بتجري. It's very similar to gravitational potential. Honestly, they're actually called electric potential and magnetic potential. طيب. Okay? Okay. Methods of energy transfer قصدي بيها ايه بقى? You know that, and let's spoil something. Law of conservation of energy بتقول ايه? Energy cannot be created or destroyed, صح? It can only be changed from one form to another, which means we can change energy from one type to another. يعني from chemical to sound. أنا بتكلم أهو, صح؟ بس all of the methods of transferring energy are considered work. If you apply a force, we call this mechanical work. عشان كده ساعات if you've solved a few past papers before, sometimes they use the term mechanical energy. They mean mechanical work, kinetic, gravitational, كده يعني. Okay? طيب. Electric work يعني electric ايه؟ Current. So this is force. When you apply a force بيحول حاجة. Current, that does work. Heating, that's a method of doing work. Waves, that's a method of transferring energy. خلاص. And all of our other units, by the way, unit 2, unit 3, unit 4, all of these, if you haven't noticed, the unit 2, this is unit 3, this is unit 4, all of these are just methods of transferring energy. So all of the other units are just us discussing in excruciating detail how do we transfer energy. قصدي ايه بقى examples of the law of conservation? That's what was said. And know how to apply this to complex examples. So let's take one example that I'll pull out of my head right now. Right now, I decided to be an athlete. طبعا I don't have the body of an athlete right now. Plus, 20 years ago, I had a body of an athlete. I was very, very, very athletic. I could run like, 10 laps around a 1.5 kilometer track, like easy, and then just go work out بعديها. But let's assume I am that person now. This is me 20 years ago. Okay. If I decide to go running and I go faster and faster and faster, what am I changing? What's the energy change? From chemical that's in my body to kinetic, because I told you my speed is increasing. That's the condition. But there is also heat because my body produces heat, and there is friction or air resistance or drag. As I'm running, I've started to climb up a hill. So I'm running up a hill. I look weird here, بس يلا. But I'm not speeding up. I'm moving at a constant speed. كلمة constant speed يعني immediately kinetic energy مش بتزيد. It's constant. So if I'm climbing upwards, what am I changing? Chemical برضو. It's not kinetic. طالما speed is constant, speed ما قلتش. So kinetic has not changed. I'm burning my own chemical energy to صح gravitational potential energy or gravitational plus heat usually. Most of the time هتلاقوا شوية heat طلع. Okay? طب if I reach the very top and then I finally stop, I still have kinetic, by the way. It's just not increasing. But now when I stop, the kinetic has dropped. وتحولت كلها لإيه؟ لheat خلاص. Like your body starts to exert or emit a lot more heat. There was a lot of friction to make you stop. Like even if you don't think about it, in order to stop your body, you need either for your muscles to exert enough force and waste energy to stop you, slow you down, or there's friction with you and the ground and friction with the air, drag, those heat. These are lots of stages زي ما انتم شايفين. Okay. طبعا now I'm too tired. I'm just going to sit down and rest for the rest of the day. Just like climbing up those stairs are enough for me. كفاية. Why is it harder for you to run up the hill? Wouldn't you need more kinetic energy? Of course you would, but it's not you need more kinetic energy. Then you need more chemical energy, because what is giving you your kinetic energy أصلا in the first place? Chemical. الأكل اللي في جسمي, like what I've stored in my body. اللي يكون في البايو بقى الجلايكوجين بتاعك وبقى والميتوكوندريا بتاعتكم, which is the energy powerhouse of your cell, والATP وازاي بيغير, like you understand the biology behind it. It's your chemical energy that turns to kinetic. But if you're climbing, of course it's hard, because when you're climbing, you actually need to do two things. You need to maintain your kinetic energy. خلاص? So you don't want to lose this, and you need to climb. So the force that your body has to generate needs to do two things: to overcome air resistance and friction عشان يفضل ده ثابت, and to overcome weight, the force of gravity, عشان يدوكوا gravitational potential energy. So that's why it's harder to run up. تقول لي sure I'm not running faster, بس علشان maintain السبيد بتاعتي وافضل نفس السبيد لازم اعمل ايه؟ energy اكتر, because I have to make up for the air resistance وال gravitational potential energy. So that's why it's harder. Okay. You're welcome. طيب. We've talked about work a lot. So when climbing both chemical and gravitational kinetic. No. When climbing, وخدي بالك تاني. When climbing, I've already put a condition called constant speed. The chemical isn't turning to kinetic. Your kinetic is steady. It's constant خلاص. Your chemical is changed to gravitational potential energy and heat. So your chemical is turned to gravitational. And heat, because you're going against friction, to prevent it from decreasing your kinetic. يعني في friction جاي عايز يقلل الكاينتيك بتاعكم. So you have to make up for it by adding some more chemical energy. Get the idea? يعني when I'm running up في air resistance. ده غير gravitation. We've already agreed. Part of my energy راح للgravitational to go up. The other part is used to make up for the loss of kinetic علشان في air resistance و friction. تخيلوا لو ما كانش في air resistance أو friction, I would need to do less effort because now nothing wants to slow me down. And this is what, على فكرة, this is what happens when you go ice skating. If I go ice skating and I push myself a bit واسيب نفسي, I just slide, صح? Why? Because I've already successfully converted the chemical to kinetic وما فيش حاجة بتاخد مني kinetic خلاص. There's no heat lost. So I just keep gliding. طبعا في الحقيقة في friction بسيط, which is why you do eventually stop. So you do need to add a little bit more kinetic from your chemical source to keep moving, like if you're ice skating. طبعا هنا in my example when I'm running and climbing في friction و air resistance كتير. That's why it needs more effort. زي الفل. Excellent. Let's define work. What we're doing now is work. But so when it comes to mechanical work, it's the transfer of energy. Like any kind of transfer of energy is called work. But the mechanical work is when you apply a force on an object and make it move. Like a phone that you lift up, up, up. Ooh, notification. لا, I'm get distracted, obviously. Up, up, up. You pushing it up is what? انت بتعمل work. You're applying a force, you're doing work. You push it a distance, you've done work. معناها you've given it your energy. فلو فكرت فيها, it is chemical to gravitational. What does it depend on? Two things. The amount of work that you do. وخدوا بالكم, there are two symbols that are acceptable for work. يا إما بنقول W يا إما بنقول E. Because work is energy, it's transfer of energy. فبنقول E. الدلتا simply معناها change. The delta E is change. بس مش مهم احط الدلتا ولا لا. So E equals FD او work equals FD. Force times distance. بس which distance? The distance in the same direction of the force. So if you're pushing an object forward and it moves a distance forward, يبقى لازم force times distance دول in the same direction. If the motion is vertical, يبقى force and distance are both vertical in the same direction. And if you're pushing something up a slope, انت بتزق حاجة على slope, distance هي along the slope, على distance بتاعت slope دي, angle بتاعت slope. You can say they could be parallel to each other. مش زي moments اللي هي perpendicular. هنا force and distance are parallel to each other in the same direction. مش perpendicular to each other. حلو كده? That's work. Since work is the transfer of energy, it's also measured in joules. Like the unit is still joules. Next, power. What is power? وpower دي مهمة قوي because هنشوفها في unit 2 تاني وهنشوفها في unit 4 تاني. So you need to keep it in mind. It's defined as the work done per unit time or energy transferred per unit time. How fast you transfer the energy. The equation بتاعتها is work over time or energy over time. And the unit is watts. Which means if I tell you you have a light bulb that's rated at 100 watts, دي معناها إن it uses up 100 joules of electricity per second. يعني every 1 second بتtransfer 100 joules of electricity. Every 1 second بتtransfer 100 joules of electricity. ده ده power. So power increases the less time you take. Like if you take less time to perform an action, this means you have more power. If you take more time, that means you have less power. Good. Last thing about efficiency. What is efficiency? Efficiency is just a ratio of the useful energy output or power output divided by the total energy input or power input. عشان تفهموها, besides the formula, عشان تفهموها, take a look at these two examples. Here's an example of a light bulb that takes in, this is your input, of 60 watts, ده power. Okay? And if it gets an input of 60 watts of electricity and it gives out 15 watts of light, a light is what we consider useful. ماشي يا جماعة؟ ده اليوسفول. هدف انها تديني لايت. طب بقت ال 60 راحت فين؟ ال 45 دي راحت فين؟ بقت هيت. دي تعتبر ايه؟ wasted energy, lost energy. مش عايزها. مش موضوع مش عايزها. انا عايزها بس هي راحت مني. So what is the efficiency of this light bulb? تعالوا بقى نشوف الفورمولا بنستخدمها ازاي. بنقول ال useful energy output which is 15 divided by the total energy input or power input ادي 60 times 100. The reason why احنا بنقول times 100 عشان نقلبها ل percentage. بنقول 15 over 60 times 100 يطلع 25%. 25% معناها ايه؟ معناها ان 25% of the energy was useful. الباقي راح على الفاضي. تاني 25% the energy was usefully transferred. الباقي راح على الايه؟ على الفاضي. Gone. Done. Bye bye. This is a terrible light bulb. ودي اللايت bulbs القديمة على فكرة. Like very old tungsten and filament lamps. Tungsten filament lamps كانت بتشتغل كده. You pass a current through it. تسخن. فلما تسخن تطلع light. To the point where if you touch it, you would literally burn your hands. It was impossible to touch. It was very dangerous to touch. طب, we call this light bulb a low efficiency light bulb. It's terrible. طب, what about a better efficiency light bulb? A high efficiency light bulb مش معناها انها بتطلع energy اكتر. It means it wastes less energy. فلو بصينا على اللايت bulb التانية دي, it gives you 15 watts of useful light over and 5 watts of wasted heat. فالtotal energy input is 20. والuseful energy output is كام؟ is 15. احسبوا الefficiency. هنقول 15 over 20. Look, the useful is the same, 15. التوتال اتغير عشان الويست اتغير. times 100. يطلع كام ده؟ يلا 15 divided by 20 يطلع times 100 75%. يعني 75% of the energy is usefully transferred. استفدت منها. And 25 is wasted. راحت على الفاضي في الهواء ملهاش لازمة. اوكي؟ بس that's it. دي الافشنسي. Now هقول بس ملحوظة صغيرة قبل ما احل مسألتين كده على الانرجي والافشنسي والكلام ده كله. اوكي؟ مشكلة الافشنسي في أي مسائل efficiency questions involving efficiency هي figuring out from the question what's input and what's output. That is the only difficult part. And that has to do with your ability to read the question and understand the device اللي بتكلم عنه. Like a light bulb معناها إيه؟ electricity هو input والlight والheat هما output. useful هو light, heat waste. So if I give you something like a car, for example, the kinetic energy is the useful output. The chemical energy is the total input. The heat is the wasted. So usually in questions, you will find some kind of hint that helps you understand this. وهنشوف دلوقتي. My bad. More time is less power? Absolutely. لو رجعنا بس تاني للpower. If a light bulb has more power, this means it gives you more energy in less time. Or if you have an electric car, for example, an electric vehicle that has more power, this means it gives you more energy in less time, or the same energy in less time. It's faster. So if you have two elevators, if you've ever been to Dubai or to Burj Khalifa, you know that they have an elevator there that rises up like 100 floors in less than a few minutes, in less than a minute or something. صح? Whereas if you have a regular elevator in a regular building, it takes like a minute or sometimes more to go up like 5 floors or 8 floors or 10 floors. صح? So Because it has less power. The more power you have, the less time you take to do that work. Not Egypt. Come on, it's not Egyptian elevators, بس. It's very, very old Egyptian elevators. ماشي? Okay. Yeah. This is from June 22. Variant 2. بص بقى بيقول ايه. Let's use the formulas we just learned. When fully charged, the battery, because you have an electrically powered bicycle, and it has a battery. The battery can deliver a power of 600 watts for 60 minutes, maintaining power and time. Calculate the energy in joules stored in the battery when fully charged. فاحنا عارفين ان power is energy over time or work over time. If I want energy, هنقول energy is a power times time. That's step one. هنقول E equals PT. فهنقول 600 times 60. بعد كده هتيجي تقولي لي ايه ده مستر this is 3 marks there's a trick. اقول لكم there's a trick. لازم المينتس exactly صح. لازم المينتس تبقى seconds. I cannot leave the time in minutes. لازم تبقى SI. فهنعمل 60 times 60. So 600 times 60 times 60. Which gives me a big value. Again, if you find numbers that are really large on your calculator, يعني on my calculator, I got 2160000. I can write it down كده. أنا ممكن أكتب الرقم كده عادي أو نحولها standard form. فيطلع لي 2.16 times 10 power 6. دي أوكي ودي أوكي. They're both okay. State the form of energy stored by the battery. إيه النوع الانرجي اللي في الباتري؟ Excellent يا محمد. Chemical. The bicycle has a motor. بص بقى. Bicycle has a motor with an electrical input power of 250 watts. Calculate the time for which the battery can power the bicycle. يعني عندنا battery بتدي للانرجي بتاعتها للموتور اللي هيلف. The motor بقى بيقبل الباور from the battery or the energy from the battery. Remember الباتري فيها 2.16 10 power 6 joules of energy دلوقتي. It's fully charged. It's fully charged. بيقبل الباور at a rate of 250 watts. يعني 250 joules per second. هياخد وقت قد ايه عشان ياخد كل الانرجي من الباتري؟ يعني how long can this bicycle work for at 250 watts دي؟ يلا. Energy, power is energy over time. يبقى time is energy over power. 2.16 times 10 power 6 over 250 watts. يعني هديفايد ده by 250. هيطلع لي 8.64 times 10 power 3 seconds. So now we know how long this bike can work. If you don't get a sense of this, خلينا أحولها لكم الرقم that you can understand. If I divide this by 60 هيطلع لي 144 minutes. يعني البايك ده ممكن يشتغل لمدة حوالي ساعتين وتلت، ساعتين ونص، like 2 hours and 20 minutes كده يعني. Consider this bicycle compared to a small motorcycle. ايه ده؟ ايه الفرق ما بين الموتورسايكل والبايسيكل؟ اللي مش عارف الفرق. This bicycle is electric. الموتورسايكل بيستخدم ايه؟ fuel. fossil fuels. فبيسألني على حتة كده environmental كده. So can you tell me environmentally something that احنا هنقولها النهارده because we're going to talk about energy resources. بس حلو. I want to see what you think. Less pollution. صح. بس. No carbon dioxide emissions. مفيش greenhouse gases. The fuel that we use is non-renewable. مش كده ولا ايه؟ So all of these are environmental issues. خلاص. فممكن نقول you know less contribution to global warming because of the heat produced by the motorcycle and no or طبعا هي no أصلا. ممكن نقول less air pollution or less carbon dioxide emissions. اوكي. طيب ما اقدرش اتكلم على الافشنسي، ما اقدرش اتكلم على الكوست. I can't talk about them. Aren't those the same points? They're not. Because air pollution حاجة which is smoke والكلام ده كله. Like أقول لك حاجة, if you don't شيل دي. If you think that CO2 emissions and global warming are the same thing. بس air pollution حاجة which causes smoke and smog and carbon dioxide and carbon monoxide poisoning and just carbon particles in the air. و global warming حاجة تانية. And it's not just the carbon emissions, it's the heat emission بتاع الانجن كمان. ان الانجن نفسه بيسخن فبيemit heat في الاتموسفير، والاتموسفير in general بيبقى اسخن بسبب الموضوع ده. اوكي. بس I cannot talk about efficiency or cost في السؤال ده because he explicitly said environmental benefits مش advantages وخلاص. تمام. excellent. طيب one more question كده وتعالوا ناخد بريك بعديها عشان مش ناقص كده غير شوية حاجات بسيطة pressure وبتاع. بس we can take a short break to get a drink. This is June 22 variant 3. خلاص. Water is held in a behind the dam in a hydroelectric power scheme. هنتكلم عن الباور schemes دلوقتي او الهيدروelectric stations دلوقتي. بس when water is stored in a dam in a hydroelectric station, it is lifted up, and if an object is lifted upwards بتبقى gravitational potential. excellent. كلكم صح. GPE او gravitational potential energy. طيب ندخل بقى في actually question احنا عايزين. Water is released from the dam and falls a vertical height of 410 meters at a rate of 480 kilograms per second. Calculate the rate at which energy is transferred by the falling water. كلمة rate, word rate معناها over time. فلما يقول لي rate of energy يعني قصدي energy over time، يعني هو عايز ايه؟ exactly صح يعني power. Power is energy over time. طب what kind of energy did we say is in the water? Gravitational. فنقدر نحسب gravitational هنقول mgh over time. طيب هل معايا الماس؟ Yes. 480 كيلوغرامز. هل معايا الجي ب 10؟ ليه؟ عشان دي جون 2022 فالجي كانت ساعتها ب 10. من 2023 انا هقولها دي لحد ما تزهقوا مني وتحفظوها. في 2023 الجي بقت ب 9.8 عشان كده لما راجعنا امبارح قلنا الجي ب 9.8 times what's the height اللي هي الاتش 410. ادينا استخدمنا الرول بتاعت البوتنشال انرجي. بس مستر هو ما ادانيش تايم. This is where this comes in. No, it's not the speed. Huh? It's not the speed. لما يقول the water falls at a rate of 480 kilograms per second, this is two pieces of information. This is telling you that a mass of 480 kilograms بتقع every 1 second in a time of 1 second. And it tells you how much water falls per second, مش how fast it is, because fast means distance. Distance over time دي اللي اسمها speed. Anything else is called rate, because speed is explicitly connected to distance traveled. فأنا كده عندي two pieces of information. الماس ب 480 لو التايم ب 1 second. So I'm just going to put the time ب 1 second. Time ب 1. ف 480 times 10 times 410. طبعا again giant number like 1,996,000. I'm just going to change this to standard form to save myself the hassle of accidentally writing an extra zero or one less zero. بما ان دي rate of energy transfer, what's the unit of power? Watt. هو مش عايز joules، هو عايز watts. This power scheme supplies a current of 270 ampere at a voltage of 6000. شوفوا ازاي سؤال energy work and power completely like this is supposed to be an energy question جاب لي سيرة electricity. فعلشان احنا لسه ما راجعناش مع بعض electricity ف I've written the formula for you. عشان نحل دي هنحتاج equation بتقول power is voltage في ال current V في ال I. excellent صح يا زين. power is voltage times current. دي من unit 4. So we can calculate the energy of this power station, oh sorry, the power output of this power station بدي. فيلا, power is V of I, which is 270 times 6000. دي اسمها V ودي I. هنقول ده times that 6000 times 270 gives us 1.62 10 power 6. Calculate the efficiency. Yalla, we know the rule. Efficiency is equal to the useful output over the total input times 100. I have two values of power here. 1.97, 1.62. مين الأوتبوت ومين الانبوت؟ في 3 طرق تفكروا فيها. Thank you. The first, زي ما انت بتقول كده ياسين, the first is ايه؟ and you realize that كلمة supplies or supplied يعني this is your ايه؟ your input. صح؟ لا. out. ليه بقى؟ Because قال لي this is about the entire power station. You need to get the entire idea of this. This is a power station that takes in water and gives you output. For this power scheme supplies us. It is not supplied to the scheme. It supplies us with this power. فده الأوتبut. Another way is to think of the scheme itself. ال question كله. This is a power station. خد gravitational potential energy وتحولت ل electrical energy. So whatever we calculated here, ده الأوتبut. And third, this is the easiest thing to consider. ان الانبوت لازم يبقى دايما الرقم الكبير exactly. لازم larger number يبقى الانبوت smaller number يبقى الاوتبوت. There is no such thing as more than 100% efficiency. ايه دخلت 100 جولز اداني 120 مثلا جول؟ makes no sense. ما بيحصلش. ف you have three ways of determining this. Either انك تفهم من اللانجوج او تفهم من الايديا بتاعت الديفايس او look at the numbers and look which one is bigger. The bigger one is definitely the input. 1.97 10 power 6 وفوق هنا 1.62 10 power 6. بعد كده كله times 100. طبعا 10 power 6 cancels out the 10 power 6. يبقى 1.62 over 1.97 times 100 يطلع أنا سايبها standard form. Okay. 82.2335. فنقول 82.2%. There we go. شفتوا بنستخدم efficiency ازاي؟ Man, that's the slightly challenging thing about efficiency. That's how it works. Okay. Very good. Now, I'm gonna pause for a second. Okay, so what's left about? A couple of things. First, let's talk about pressure. What is pressure? Let's look at the checklist. Pressure is defined as the force per unit area. You should know that. And recall and use the equation force over area. Okay. Describe how pressure varies with force and area in the context of everyday examples. So we're going to do a lot of stabbing. Exam pressure, not that kind of pressure, unfortunately. But yeah, exam pressure, study pressure, IG pressure, life pressure. Describe qualitatively how the pressure beneath the surface of a liquid changes with depth and density, as in you should be able to talk about how the pressure under liquid changes and how it changes based on how deep you are in the liquid itself. Recall and use the equation for the change in pressure beneath the surface of a liquid. Pressure of a liquid equals rho GH. We'll talk about that as well. So we're going to calculate liquid pressure. فتعالوا نتكلم بقى على pressure. What is it? Force per unit area. قصدي ايه؟ قصدي ان when you apply a force, we no longer just look at ايه الفورس اللي بنعمله. لا. We also look at the area over which that force is applied. So if this area is very small, once you apply a force over a small area, what will happen to this piece of paper? It will just go through. It will get torn and the pen will go through. But if I get the same sheet of paper and I apply a force with the other end of the pen, which is flat, and I just apply a force on that sheet of paper, It's not a going through. So just so I can be fair, here you go. So you can even hear me tapping it hard. I'll do the same thing with the sharper end or the pointier end. It just goes through right away. Okay. So what is it? It's how the force is distributed over a certain area. The smaller the area it's applying the force, the higher the pressure. Like it's super concentrated, the pressure is very high, it breaks through the floor, for example, or the sheet of paper. If I do the opposite, but if I increase the surface area, the pressure will decrease. Because all that force is spread out over a large area. الفورس ده بيتوزع على area كبيرة. Spread out. فالpressure بيقل. هنا all of the pressure or the force is focused on a single point. How do you calculate pressure? Pressure is equal to force over area, which means in the pressure is directly proportional to force inversely proportional to area. لو زودنا الفورس pressure يزيد ولو قللنا الarea pressure يزيد. The unit of measurement of pressure is Pascal, but again that's under the condition ان احنا بنستخدم SI units فلازم تكون الفورس بالنيوتن والarea بالمتر squared to a Newton per meter A squared. Okay? Yeah. Very good. طيب. That's just regular pressure and that's definition of pressure is very simple ما فيهاش أي حاجة تانية. How do you calculate that pressure under the surface of a liquid? The equation is rho GH. Rho is the density of the liquid. G اللي هي gravitational field strength أو acceleration of free fall 9.8 و H اللي هي depth. احنا طبعا بنقولها H عشان دي height بس why do we call it depth؟ علشان لازم ال depth أو ال height ده يتقاس from the surface of the liquid to the point where you are. يعني if you're under a liquid هنا يبقى ال depth اللي بقيسها من السيرفيس لتحت مش من تحت لفوق. not from the bed لفوق الأوبجكت بتاعك. That's why you cannot call it height. إن احنا مش بنقيسها من تحت ونطلع. احنا بنقيسها من فوق وننزل. We're going down. دي معناها إيه؟ إن the greater the depth the greater the pressure. فده عنده pressure أقل التانية دي عندها pressure أكتر. And second depends on density. The more dense a liquid is, the higher the pressure. Because obviously more dense liquids are heavier and therefore they have more weight and so they apply more force and thus they apply more pressure. بكل بساطة دي pressure in a liquid. Now, it's not a very hard topic. Pressure in general is not a hard topic, but keep in mind, when we're talking about liquid pressure, please be careful. If we ask you to get total pressure, دي حاجة, liquid pressure دي حاجة تانية. Because when you're under a liquid, in truth, you have two sources of pressure acting on you. يعني when you're under water, انت actually عليك two sources of pressure. liquid itself عامل pressure, الويت بتاع liquid عامل pressure. Let's say دوت 10,000 باسكال مثلا. or 20,000 باسكال. But then في الاتموسفير اللي هو الهواء. The air also applies pressure on the surface of the liquid. Now, standard atmospheric pressure is around 100,000 Pascal, 1 times 10 power 5. ما تحفظوش الرقم ده. You don't memorize this. The question will usually give it to you if you need it. But if I ask you for the total pressure acting on you, this is due to the liquid والatmosphere. الاثنين. فالpressure هنا بكام التوتال؟ هيبقى 100,000 plus 20,000 يبقى عليا 120,000 باسكال. So please keep that in mind واحنا بنحل مسائل if he ever asks for total مش بس ايه liquid pressure وخلاص. Let's solve a couple of questions and as you can see this is a question about a generator صح؟ So a hydroelectric power station a dam هنتكلم على الدامز دي ايه دلوقتي بس when do you انت بتعمل امتى الاتموسفيريك pressure minus البريشر العادي you don't انت بص بقى atmospheric pressure plus liquid pressure يديك التوتال صح؟ rearrange this formula as you wish بقى. أنا ممكن في مسألة أديك التوتال. I could give you 120,000 باسكال total given. ومش هديك الاتموسفيريك. وأقول لك find الاتموسفيريك pressure PA. فهتعمل لي ايه؟ هتقول لي PA plus 20,000 equals 120,000 باسكال، ان دي given. يبقى ال PA equals كام؟ 120,000 minus 20,000 يطلع 100,000. مفيش حاجة امتى minus وامتى plus. It has to do with your understanding of ان السم بتاع دول equals التوتال. انا مديك ايه؟ مديك التوتال ولا مديك الليكويد ولا مديك الاتموسفيريك؟ you just rearrange وتجيب الانون. طيب يلا. Figure 2.1 shows water stored behind the reservoir in a hydroelectric dam. State the form of energy stored in the water in the reservoir used to generate electricity. عشان it's high up. We already answered this question earlier. هنقول gravitational potential energy. Done. This is just part A of the question. ما حبيتش اشيلها because part B the AI و BI و double I خلاص are pressure questions. The turbine is 150 meters below the level of the water of the reservoir. فمديني height from the surface to this point. خلاص. The atmospheric pressure is 1 times 10 power 5. So he's giving me the atmospheric pressure that's up here. The density of the water is 1,000. Calculate the total pressure. مش liquid pressure, total pressure in the water at the turbine. يلا نحسب البريشر ازاي. تقول لي يا مستر total pressure under a liquid is the pressure of the liquid plus the pressure of the atmosphere. Pressure of the liquid is rho GH plus البريشر بتاع الاتموسفير. الدنسيتي بكام؟ 1000. الجي بكام؟ I mean, again, this is from 2022, for the numbers are designed على أساس إن الجيب 10 ها؟ 22 أساس الجيب 10 فيطلع 1000 times 10 times 150. حتى بصوا على الأرقام دي nice and clean. يعني هيطلع لي 1500 وثلاث زيروهات 1,500,000. هو قاصد أرقام تطلع حلوة. 9.8 will change the numbers a bit. فهي will change or the examiner will change the numbers a bit عشان تطلع برضو أرقام حلوة. plus الاتموسفيريك اللي هي 1 times 10 power 5. حط الأرقام دي كلها على الكالكليتر يلا. bracket بقى 1000 times 10 times 150 plus 1 10 power 5 يطلع رقم طويل قوي برضو. So standard form if you may and 1.6 10 to the power of 6 باسكال. أو طبعا لو مش standard form 1 6 1 2 3 4 5 zeros. Okay, so 1.6 million basically. The turbine has an area of 3.5 meters squared. Calculate the force exerted on the turbine by the water. طب احنا already في I جبنا total pressure. He gave me area and he wants force. Pressure is force over area. رجعنا استخدمنا أول رول تاني بقى. يبقى الفورس equals pressure times area. البريشر الفورس البريشر ب 1.6 10 power 6. الاريا ب 3.5. الرقم ده على الكالكليتر. هيطلع again mega long number. فنقول 5.6 10 to the power of 6 نيوتنز. شفنا ازاي بنستخدم رو جي اتش وازاي التوتال وازاي فورس عشان سوري بريشر عشان نجيب فورس. جميل صح. بس لا ثانية واحدة بقى. صح. How many marks is this? 2. And second, look at the language. Calculate the total pressure in the water. The pressure that's causing the force in the water at the turbine هو اللي نستخدمه عشان نجيب الفورس. خلاص هو اللي نستخدمه عشان نجيب الفورس. Otherwise كان هيقول لك بدي ب3 درجات because كنت لازم تحسب دي ايه لوحدها. اوكي ماشي. Nice. The water flows to the turbine through a pipe of constant area. Explain why the kinetic energy of the water remains constant as it flows through the pipe. ليه الكاينيتيك انرجي بتفضل constant؟ ان هو بس بيقول له the water throws through a pipe of cross section area. what pipe flows to the turbine؟ طب بصوا على البايب يا مستر، البايب نازل. how is the kinetic energy constant؟ مش المفروض لما تنزل الجرافيتيشن الكل يتحول لكاينيتيك؟ مش كده ولا ايه؟ so think a little bit. يا ترى ليه؟ ها، ليه الكاينيتيك طالما الكاينيتيك انرجي constant؟ it is technically it is. Let's be real with each other. Technically, it is from a higher altitude. Actually, based from because water is way up there, the gravitation changed to kinetic لما نزلت. But through the pipe, sorry, خلاص. Through the pipe هو قال the kinetic energy stays constant. طالما kinetic energy stays constant حاجة من الاثنين. Either there's no energy change أصلا, like فكروا فيها, there's absolutely no energy change going on. Maybe, like even though هو رسم البايب نازل. أو something else is wasted or wasting the energy. فكروا تاني كده اهو، يلا. هسيب لكم الرسم. Maybe something is wasting the energy. Do you think is anything wasting the energy؟ ولا ايه؟ It's a very simple answer by the way. ممكن تبقى thermal، بس هقول لكم حاجة تانية. Look at the question. This is more of a بصراحة it's more of a density question. هو بيقول the water flows to the turbine with a constant area. The kinetic energy remains constant as it flows through the pipe. طالما ال kinetic energy remains constant and the area is constant and the speed is constant. وهقول لكم حاجة, maybe this is not much of an altitude difference. Maybe this is not much of an altitude difference. خلاص؟ ليه طيب it's moving at constant speed؟ الكيورد هنا كانت area. keyword هنا كانت area. هو ساب الانرجي خلاص. This is not an energy question anymore. This is simply about إن طالما المية ماشية at a constant speed, يبقى ال amount of water that's going in has to be equal to the amount of water going out. If this area is constant, even though هو مش راسمها قوي, يبقى the amount of water going in equals the amount of water going out. الدليل على كده إن speed is constant والarea is constant. طيب عشان تفهموها أحسن شوية so you can understand this better. What if this pipe was open like this؟ والمفروض الطبيعي ان الامount of water going in قد الامount of water going out, يعني ده عادي. Will it have the same speed؟ Will this have the same speed اللي داخل والخارج؟ No, because the area changes. And if the area is larger, ده كده في مية أكتر بتخرج. فإيه اللي هيحصل؟ One of two things. If the speed was constant, this pipe would eventually like drain out وما يبقاش فيه مية because it's like extracting way too much water. أو if it's still full, the amount of water going in قد the amount of water going out, the water here would be slower. Because اللي داخل بسرعة ده has to fill up this area وهو ماشي. Whereas هنا, because the area is constant, this is perfectly full. There's no sudden change and it's bigger and goes like, oops, oh, we need to fill this up first. And there's no sudden change to make it thinner. فالمية لازم تمشي أسرع. So this is more of a logical question. More of a logical question about the volume of the water and how the volume of the water doesn't change. Why does the kinetic energy remain constant? It's very misleading بصراحة. هنقول because طالما the kinetic energy, since the kinetic energy is not changing, the speed is constant. So the amount of water flowing into and out of the pipe is the same. Okay. Not really a pressure-related question, but let's look at a question that is pressure-related. Figure 3.1 shows a person moving across. Could you explain this again? You don't get it? Okay. This question asks you why the kinetic energy of the pipe remains constant as it flows through the pipe. No, I want a red border. Here's a pipe. You have water going in and water going out. If the kinetic energy is constant, this means there's no energy gain, no energy lost. So the speed is what? Also constant. If the speed is constant, okay? If the speed is constant, why is the speed constant? Because the area is constant. Like you're applying a certain amount of pressure, which pushes the water in. If the area changes of this pipe, دي حتة كده volume. It's more of a common sense question, as I said. If the area of the pipe changes, if you had a pipe that suddenly became thinner, like same input, same output, but it's thinner here, what's going to happen? Will the kinetic energy be constant? Will this kinetic energy be constant? No, because as soon as it goes in, or maybe it is, إيه اللي هيحصل? The water here has to move faster علشان تعرف تطلع بنفس الامount. المية هنا تمشي أسرع because now it's narrower, so it has to travel faster to get out of this pipe. So it moves faster because the area is not the same. Honestly, his use of the word kinetic energy is very misleading in this question. He could have simply said, explain why the speed of the water remains constant as it flows through the pipe. That would have been a much easier question because now it's not related to energy. It's just related to speed. The speed is constant because the pipe has a uniform area. And since it has a uniform area, the amount of water that's going in is equal to the amount of water going out. It has the same speed. This is why the keyword here is actually constant area. Kinetic energy was only there so we can add one more mark وتقولي له ايه if the kinetic energy does not change يبقى the speed does not change وطالما the speed does not change يبقى the amount of water going in equals the amount of water going out. Makes sense because the area is constant. دي الإجابة. His use of the term kinetic energy here was very misleading عشان بيحاول يصعبها سنة اللي هو هي ليه kinetic energy constant كده يعني. Yeah, next. Figure 3.1 shows a person moving across an ice-covered pond to reach a ball on the ice. Explain why this way of moving across the ice is safer than walking. طبعا لما ينام كده ايه اللي بيحصل؟ His surface area increases. ولو surface area زادت البريشر بيقل. According to what? To the equation. فهقول له according to pressure equals force over area when the surface area increases, the pressure decreases. So he won't break the ice. فنقول له area زاد, pressure قل, he won't break the ice. So we've explained why it's safe. We've explained in terms of pressure, and we gave him the rule. This is why use your understanding of pressure. I have to include the rule, unfortunately, عشان it's 3 marks. Next, figure 3.2 shows a side view of the pond with a layer of ice floating freely on the water. The surface area of the pond is 5 meters squared. The mass of the ice is 690 kilograms. The density of the water is 1000 kilograms per meter cube. Somebody changed the captions to Deutsch, I don't know why. Point X is 0.45 meters below the ice. Calculate the pressure at point X due to the ice and the water. الاتنين. So how many pressures am I working out here? اتنين. The ice is a solid. And what has he given me? He's giving me the mass of the ice, which I can use to get weight or force. He's giving me the area of the pond, which is the ice. So using force and area, I can get the pressure of the ice. He also gave me ايه بقى؟ the density of the water and the depth. فأنا ممكن بدول أجيب الليكويد اللي هي الwater. يلا. Pressure of the ice equals force over area. الفورس بكام؟ It is the weight of the ice. الماس ب 690. This is 2023 فنقول عادي mass times gravity mg over area. الماس ب 690 times 9.8. الحمد لله I can use it now. Over what's the area? 5. 690 times 9.8 over 5. هيطلع 1352.4. Then أنا عايز ال pressure due to ice and water. فيلا pressure of the water is rho gh, which is 1000 times 9.8 times the height low 0.45. Plus 1000 times 9.8 plus 0.45. خلاص اللي هو 5762.4. What do we do with these two بقى? We add them. You add these two. فيطلع لي 11,152.8. I'm just gonna say 11,153 Pascal. So we've used both pressure equals force over area and rho gh في الquestion ده. And we used our understanding كذا. Okay. So let me check one more time. Maybe I'm wrong. 0.45 plus 1352.4. Yeah, my calculator bugged out. I'm sorry. My calculator bugged out for a second. The total is 5762.4. This is 4410. And this is, I don't know why they do that. Weird. This is 1352.4. Okay, very good. Last bit بقى. Last bit. This is just a bunch of us يعني things that we're going to discuss. هنرغي فيهم حبة حلوين. Of course, if you need to leave, leave, no problem. This is just something we're going to discuss. It's not very common. خد بالكم في الأسئلة. بس as we've seen in the previous questions حلينا سؤال pressure وحلينا سؤال energy. And in both of these questions, energy والpressure طلب مننا إيه؟ What's the gravitational potential energy? What's the gravitational potential energy اللي في الدم? So we're going to just quickly describe how each type of power station changes or like generates electricity. Okay. First, checklist. Describe how useful energies may be obtained or electrical power generated from chemical energy stored in fossil fuels or chemical energy stored in biofuels. Both of these are chemical, زي ما قال, and we burn them to generate heat, and that heat is used to turn a turbine and a generator. Water, including energy stores in waves, in tides, and in hydroelectric dams. ثلاث أنواع water. Geothermal, which is geothermal, which is heat from the earth, underground heat from the earth. Nuclear fuel, usually uranium or plutonium, depending on what we're doing, for nuclear fission, which is when you break an atom, you break a nucleus into smaller nuclei. Light from the sun to generate electricity, so solar cells. Infrared and other electromagnetic waves from the sun to heat water and be the source of wind energy. So we're going to talk about how the sun is the source of wind. Include references to a boiler, turbine, generator, where they're used. You basically have to describe very briefly how each of these work. There are a lot, but they all share the same things. يعني كلهم عندهم نفس common points to talk about. State the advantages and disadvantages of each method in terms of renewability, availability, reliability, scale, and environmental impact. Know that radiation from the sun is the main source of energy for all of the types except geothermal nuclear tidal. Like all of the other types come from the sun ما عدا الثلاثة دول. And know that energy is released by nuclear fusion in the sun. فالsun أصلا بتاع nuclear fusion. And finally, know that research is being carried out to investigate how energy released by nuclear fusion can be used to produce electricity on a large scale. أديكوا عرفتوا. We are currently doing a lot of, like, مش currently حتى ده من زمان قوي. We've been trying to achieve nuclear fusion here on Earth زي اللي في الشمس عشان generate بيها electricity كتير. Anyway, very briefly بس كده في السريع. كل الchemical power stations whether the biofuel أو coal أو oil أو gas تشتغل كده. You burn the fuel, you boil water, the water turns to steam. الsteam بيلف في turbine which is just a big fan. الturbine ده بيلف في generator which is a coil inside magnets. And the generator generates electricity. Chemical to heat to kinetic to electric. دي energy sequences. Nuclear fuel uses a very similar thing. النوكلير بنعمل ايه؟ بناخد nuclear reactor خلاص يحصل فيها nuclear fusion. What is nuclear fission? What is nuclear fission? لما بناخد nucleus and we break it. Usually it's uranium and a very slow moving neutron بتدخل جوه it gets absorbed bam اليورانيوم ده بيفرقع. فلما يفرقع بيريليس heat و light. Basically a nuclear bomb. If you've seen Oppenheimer, you get the idea. So the nuclear energy turns to heat. I don't care about the light. And that heat is used to boil water. The water turns to steam. The steam hits a turbine. Turbine spins the generator, generates electricity. Geothermal بقى. When you dig underground, the temperature of the earth increases. يعني الرocks اللي تحت الأرض بتبقى سخنة. So what we do is we dig underground, we pour or pump water underground. الwater دي هتبويل بسبب الهيت from these rocks underground. فهيطلع لنا منها hot water أو steam. الsteam هيخبط التربين بيلف generator and generate electricity. So it's heat to kinetic to electric. Next. The water بقى types. First one is easy. Waves. بنعمل إيه؟ We put a turbine, like a big fan or like something that flaps up and down in the water, and when waves hit it, it moves. And when it moves, يا إما بتروtate يا إما بتقعد تبوب up and down, بتحرك generator, and the generator generates electricity. فالwaves تخبط التربين بيلف الجنريتور بيعمل electricity. So kinetic to electric. الهيدروإلكتريك I'm skipping tides هرجع لها بعد الهيدروإلكتريك. الهيدروإلكتريك زي السد العالي في مصر. We have a giant hydroelectric power station which is just a dam that blocks a river. والriver ده فيه ميه. This water بتعمل ايه؟ الميه دي بتروح عامله ايه؟ بتفلو down فبتغير gravitation potential energy لkinetic. وبتلف turbine والturbine بيلف generator والgenerator بيطلع ايه؟ electricity. طيب الهاي تايد بقى واللو تايد اللي هو التايدل. If you don't know التايدز بتاعت الأرث اللي هي المد والجزر ان الووتر ليفل بتاع الاوشن بيعلى او بينزل. This is due to the moon, due to the gravitational force of the moon. فساعات الليفل بتاع المية بيعلى on earth عشان المون في الحتة دي. So when we have high tide الليفل بتاع البحر عالي احنا بنبني دام وبيبقى عندنا سبيس فاضي كده كبير خزان كبير storage space للمية. This is what we call a reservoir. It's just a space to store water. فاضية, it's empty. But there's a water level difference here. So the water flows out بتطلع لبره. بتدخل لجوه. عشان دي عندها gravitational potential energy to kinetic energy. Turbine spins the generator generates electricity. So gravitational to kinetic to electric. الاتنين زي بعض بس source of hydroelectric is usually a river or a lake. ميه متخزنه او water that's flowing that comes from rain. السورس بتاع التايدل برضه gravitational بس it comes from the high and low tide of the ocean. Do you need to know the steps? Very briefly, yes. What's written in the diagrams is all you need to write. During high tide, the water flows through a turbine into a reservoir. And that turns a generator, and generator generates electricity. That's all you need to know. Do you have to memorize the diagrams? No. You won't be asked to draw, but you will be asked to briefly explain. Light from the sun can be used to generate electricity using solar panels. So all we do is we put solar panels, they get sunlight, there's no turbine, مفيش generator, مفيش moving parts خالص. It's just, an electrochemical reaction بيحول اللايت لإلكتريستي على طول. Okay. And finally, wind turbines. انتوا probably شفتوا الwind turbines دي كتير. It's the most common type of thing that you see that actually moves and it looks very cool. لما الwind بيخبط الturbines دي, it turns, and when it turns the generator, that's literally the part behind it, وبيعمل regenerate electricity. So it's kinetic to electric. Now, عايز أقول حاجتين. First, there is a very important advantage and disadvantage, and that comes from the term reliability. You're all familiar with pollution. فانتوا عارفين طبعا الفossil fuels بتعمل air pollution, contributes to greenhouse gases. النوكلير fuel بيعمل nuclear waste, that's the type of pollution which is radioactive, ده الخطر فيه. All the other types of renewables do not cause pollution. That's their advantage. بس الادفانتج بتاعت power stations دي that use heat, اللي هو الكيميكال والنوكلير فيول والجيوثيرمال, is that they are reliable. يعني ايه كلمة بقى reliable؟ يعني يعتمد عليه في ايه؟ generate electricity ليل ونهار, morning and night, مفيش ايه حاجة بتوقفه. it doesn't depend on the weather. ففي مطرة مفيش مطرة بجنريت electricity, في شمس مفيش شمس بجنريت electricity. مشكلة بقى كل الرينيوبلز دول ما عدا الجيوثيرمال بصراحة, كل الرينيوبلز دول they are reliant on the weather. لو في wind هيعمل waves فهيجنريت electricity. الويند لو وقف مفيش waves مش هيجنريت electricity. الهاي تايد واللو تايد مضمونين, بس they're not going to generate electricity all day because there are certain times of the day لما التايد بيتغير و certain times of the day التايد مش بيتغير. So you have to wait. الهيدروelectric power stations معتمدة على مية جاية from a river or lake, which means it depends on rain. فلو أنا جت عندي season مش rainy قوي, الwater level هتقل, فمش هعرف generate electricity. It has to be raining. And sunlight. I mean, this is the easiest. Sun generates electricity in the morning, but not at night. That's easy. الwind turbines, ايه فكرتها؟ لو في wind هتجنريت electricity, لو الwind speed, مش هقول لك ما فيش wind, لو حتى الwind speed قل مش هنجنريت electricity. So it doesn't work there. آخر حاجة, what's the deal with sunlight بقى؟ فكرة sunlight إن the sun is the source of almost all the energy types except for tidal, that does not depend on the sun, it depends on the moon. Geothermal, that does not depend on the sun, that depends on the heat from planet Earth itself. Wind nuclear, that does not come from the sun. This comes from metals that we dig from the core of the from the earth. مش هقول الكور, it's incorrect to say core, but from the earth. الكول والoil والgas comes from the sun. عشان these were living organisms that died millions of years ago and they fossilized under pressure and they were alive because of the energy from the sun. So that's their source of energy. That's even our source of energy. We eat the sun essentially. الwaves جاية من الwind, and the wind comes from the sun. ليه؟ Because the sunlight, the heat from the sun heats the atmosphere, فلما يبقى فيه temperature differences في الاتموسفير بيبقى فيه pressure difference, high temperature, high pressure, low temperature, low pressure, فالاير بيتحرك from high to low pressure فبيعمل wind في الاتموسفير كله. So wind comes from the sun and that affects the waves. فالwaves بتيجي من الsun and the wind comes from the sun. I think solar panels make sense براحتهم. I can't tell you how there's no sun when there's no sun. But hydroelectric also depends on the sun because it depends on the rain cycle. And the rain cycle depends on the sun. The sun heat up أو evaporate the water in the oceans to form clouds. الclouds تتحرك وبترين. So the source of energy, the gravitational energy, جاية أصلا من sun. Okay? right. تعالوا نبص على السؤال ده بسرعة بقى كده. This is from 2022, November. Figure 3.1 shows the cross-section of a barrage built across a tidal bay. The barrage is part of a tidal power station. ده التايدل اهو. تقول لي مستر بس that's not the same diagram. مش مهم. So it's a diagram. The gates are raised to open when the tide comes in. The gates are lowered to close when it's high tide. Figure 3.1 shows the water levels in the open sea, يعني ده low tide اهو, and in the reservoir تحت هنا go when the gates are open. Sorry. Complete the sentences to describe the energy transfers which take place when the gates are open. لما يفتح الجيتس والجيتس دي تفتح, المية هتخرج كده. The water flows out and it turns the turbine. يلا. Dash energy of the dash in the dash is transferred to dash energy in the rotating dash. The energy is used to produce and the generator is producing electrical power. طب أنا ممكن أبدأ بالعكس. هو what's rotating? هو مين اللي هيروتيت؟ هو already قال generator produces. هو is going to rotate التوربين. ممكن هنا أقول turbine. طيب. What kind of energy is in the turbine is transferred to the dash energy of the turbine. turbine moves فدي ايه؟ kinetic. خلاص؟ فحاجة energy of the حاجة. ايه ده؟ ده احنا بدأنا. What's our starting energy? It's always ايه؟ gravitational. فهنقول gravitational potential اللي هو كاتبها هنا. Of the water. المية هنا. In the هي المية دي فين؟ عشان هي التريك بيسألك هي في الاوبن سي ولا في التايدل باي. لا اللي في التايدل باي هو سماها, لازم يسميها ريزرفوار, يسميها تايدل باي. and the tidal bay flows out عشان هي دي اللي عالية المرة دي. ف in the tidal bay. طب ياسين, what if he did the reverse? what if الووتر ليفل هنا اللي عالية والووتر ليفل هنا اللي قليلة؟ This question would have been exactly the same, بس كنا هنغير ده ونقول open sea لو كان الليفلز مختلفة. That's it. That's the difference. State one advantage and one disadvantage of tidal power as an energy source. Advantage واضحة قوي. It is renewable. Renewable energy source. ممكن نقول it doesn't cause pollution برضو. ايه ال disadvantage? It is unreliable as we have to wait for the high or for the tides وخلاص. فلازم نستنى. Finally, state the main source of energy for the tidal energy. Yeah, what's the main source of energy? It's the moon. بالظبط كده. يعني السؤال ده حطه كتريك. لك is it the sun or not the sun? طب ماشي, it's not the sun, it's مين? The moon. تمام? This is another easy question. State two energy resources for which the sun is not the main source. فممكن نقول geothermal nuclear tidal. So all three. So you choose two of the three براحتكم. State and explain whether each of the following methods is renewable ولا لا طبعا. Power generation in a nuclear power station. نقول له it is a non-renewable. ليه؟ Because nuclear fuel comes from uranium from the earth which can run out. آخر حاجة بقى. Power generation from waves in the sea. فهنقول له it is renewable. ليه بقى؟ Because the waves are caused by the wind and the wind خلاص is due to the sun. which is renewable. يعني الويفز جايه من الويند والويند جايه من السن والسن is always renewable. خلاص. All right. Very good. We're basically done for the day. So we'll stop here.